This takes a look at Berkeley's ghost as an introduction to the limit concept in calculus. The integral is usually introduced as an area under the curve, and here we start with two rectangles, one entirely below the curve, the other with a part of its area above the curve. The width of these rectangles is the delta x, or the change in x, and we progressively narrow delta x in a sequence of rectangles, ending up with a line at their left edge. And from the other direction, another sequence of rectangles leading towards a line at their right edge. The theoretical idea is that an infinite number of these lines would represent the area under the curve. However, as delta x approaches zero, you get what George Berkeley called a ghost of a departed quantity. That is, a line really has no width and therefore no area. He said this in 1734 as a criticism of the very informal and unrigorous foundations of calculus at that time. Now, he was referring more specifically to the derivative, which I'll make a note of here. However, following Courant Robbins, I had started with integration, which was also more specific to the Fourier problem I was interested in at the time. I believe the principles should be the same for both. I may modify this in the future. In any event, I'm thinking of this as an introduction to the more rigorous epsilon delta explanation of the limit process for the general public and to be visible on a smartphone screen.